In this session we're going to get the ship to move. Now the ship doesn't actually move forwards, we're just using the particles coming towards us as an indication of moving. The best idea is to picture the whole game is taking place within a drum. So we can move the ship up or down, but not forwards or backwards, and we can rotate it. So it's pivoted in the center of the drum, and it can rotate 360 degrees around the drum to attack the oncoming enemies. Right, so we need to make sure that the jet stream here and the lamp follow the ship. So this is the particle system, which is the jet stream. I'll rename that as jet stream. And I'll rename the lamp as engine glow. And I'll make sure that they're both children of the object here, defender, so that they move with the ship. Right, so I just tag them on there. This particle system is the little bits of space dust, so I'll rename that as space dust. Okay, so if we want to control the ship, we need to add a piece of code, which I will do. I'll have a new script, and we'll call this ship control. And so we'll add that in and just wait for it to be selected. Right, now we can let's put it into the scripts folder. Right, and now we can edit it. So here's our basic class. We're going to need some public variables to start off with. And they're both going to be of the float time here. We need to be able to control how fast the ship rotates and how fast it climbs or falls, for that matter. So I'm going to call the rotation is turn speed, and I'll give it a default value of 1. We can always change this in the inspector if we need to speed it up. And I'll put in the climb speed. I'll also set that to 1. Now, as this ship rotates, I want it to bank. So it needs to roll. And as it moves up and down, as it goes up, I want the nose to point up. As it comes down, I want the nose to point down, and that's called pitch. So I'm going to put some angles in for the pitch. Oops. Pitch angle. Let's float. And I'll say, right, well, 15. And the same for the roll angle. Right, we can also change these in the inspector. Now, as I said, this whole game takes place in a sort of drum, so I need to limit the amount of climb that the ship can do. So it starts off at 0, so I shall say let's have 20 above and 20 below. So I'm going to add another public limits. This is a float. I call this V for vertical limit. I'll make that, say, 20. Right. We'll need some public, some private variables as well here. And this is going to be the, so they're going to be floats. The rotation, horizontal rotation, which I'll call H rot, and the vertical position, so I'll call that V pos. And I'll give these initial values. So initially the rotation is 0, so this is the horizontal rotation is 0, so I shall put that in. And the vertical position is also 0. Right, we've got an update, but I'm going to put the movement in the fixed update, so it takes place every physics update. So I'm going to make the fixed update. Right, and the first thing I'm going to do is to capture the left and right and the up and down keys, the vertical and the horizontal axes. Right, so I'm going to create some variables to hold those. I'll call this one H movement. And this is going to be the input get axis. And we're going to capture the horizontal. We'll put in V movement as well. Right, so let's deal with moving the ship up and down first of all. So I'm going to put here vertical movement. Now I'm going to increase or decrease the vertical position. So we'll add on, so using plus equals, let's move that up a bit. Right, so we've got the V movement, and that's going to be amplified by the climb speed. Oh, made a mistake here, should be commas there. I wonder why I didn't accept them. Okay, so we should be alright with climb speed now. And I'm going to bring that down by, multiply it by time, delta time, otherwise it'll be much too fast. Right, so I want to make sure that it doesn't climb outside the drum, so I'm going to clamp it. I'm going to use the mathf.clamp function for that. And I'm clamping vpos. I'm going to clamp it between minus vlimit and vlimit itself, or plus vlimit. Right, so that will make sure that it never gets beyond our limits. Right, so all I have to do is change the position. So I'm looking at the transform of the ship object. Right, so I just want to affect the Y position here. So I'm going to use a little trick here. So it's got to be a vector 3. and I'm going to use vector 3 up. Now remember, vector 3 has got 3 components, x, y and z. So the vector 3 up is equivalent to 0, 1, 0. So it's just the y direction. So, and I'm going to multiply that by vpos. So that's going to multiply each component of vector 3 dot up, and it'll just result in the vpos, because vpos times 0 is going to be 0, vpos times 1 is going to be vpos. Okay. Let's deal with the rotation movement. Right, so our rotation, we're going to rotate around this horizontal rotation. Okay, so I'm going to put in here hrot, which is our horizontal rotation, and I'm going to increase that by h movement, and I'm going to multiply that by turn speed. Now I want the ship to roll as it moves horizontally. Of course, really in space, spaceships don't roll. It's just something we're familiar with planes. So you could use this movement if you had a plane fight or something like that. Okay, so this would work perfectly well with that. So I'm going to make a new float, and this is going to depend on the horizontal movement. In fact, it's got to go in the opposite direction. And we're going to multiply that by the roll angle. And I'm also going to make one for the pitch. That's going to be if I didn't put this minus in, it would pitch the wrong way. Right, so I've got a new rotation now. So I'm going to create a quaternion. Now, all rotations in Unity are stored as quaternions. Now, if you've ever looked at a quaternion, it says do not try and figure them out yourself mathematically, because it's virtually impossible. So what we need to do is to put it in as a new Euler angles. Right, so the Euler angles are the ones we recognize when we look in the inspector, where we have the X, Y and Z rotation. So to do that, I need to start off with a quaternion function, which is Euler, and now I can put in my X, Y and Z components here. So the X, Y and Z components are the pitch, the horizontal rotation and the roll. Right, so we put in the X, Y, Z. That's going to be stored in a quaternion which I haven't named. So I'm going to call that new rot. Okay, so it's going to create a new quaternion based on the pitch, h rot and roll, and store it in a quaternion called new rot. Now I don't want the ship to lurch from one rotation to the other, because that'll look very jerky, and we've got this function that we can use. So put in transform rotation, which is a quaternion value. I'm going to use another quaternion function, that, and it's called Slurp. Okay, sounds like drinking hush puppies. No, not hush puppies, slush puppies. Yeah. What this does, it's a linear interpolation, so it smooths out the movement. So we're going to go from the current transform rotation to our new rotation, new rot, and we're going to scale it down by time dot delta time. Right, so that's there to smooth the whole thing out. Let's just check our code. No mistakes, it seems. So, but does it work? Let's just check out the ship. So, maximize on play. Right. Okay, so it banks and rotates around. Will it go the other direction? Yeah, so it banks the other way and turns around. Right, and the trail follows it. So you can see it's very much like a plane motion. And we should be able to go up, yeah, going up, and come down, and the nose rotates in the right direction. The one thing that does look a bit weird is now we're coming away from the space dust, so it makes us look as if we're travelling backwards, which is a bit silly really. So what we want to do is for the space dust to always be in front of the nose of our spaceship. We'll have a look at how to do that next time.